everybody, welcome back. In today's video, I'm going to break down the SN2 reaction in the most simplest and basic terms as I possibly can that really helped me understand this concept when I was taking OChem in undergrad. For starters, it's important to know that SN2 is a one-step reaction where the nucleus attacks the carbon atom from the backside. I'll get more into that as I go on. It's also important for us to know that the best leaving groups include bromine, chlorine, iodine, and TSO, also known as tosylic acid. That's actually the best leaving group for this reaction. Alcohol is never going to be a leaving group for an SN2 reaction. So if you see OH as a leaving group, you automatically know that you will not be conducting a SN2 reaction. Order of reactivity is important because of this backside attack. The least hindered carbons include methyl groups and primary carbons. SN2 will occur in secondary carbons, but it will never occur in tertiary carbons. When our molecule has a chiral center, inversion applies because of the backside attack. It causes the wedge and dash to flip, the inversion to happen. Another hint that really helps us know when we're conducting an SN2 reaction is when we're in the presence of polar aprotic solvents. These solvents are unable to form hydrogen bonds. The most common ones include these. I would go ahead and just memorize these. You'll see them under the arrow. That's how you know you're going to conduct it. I use some in my examples. So let's go ahead and start arrow pushing to understand how this reaction occurs. Okay, let's start with this first problem. The first step is that our nucleophile is going to attack the carbon holding our leaving group, and that's when the leaving group goes off. Then we draw a transition state. This is not an intermediate. A transition state just goes to show that this SN2 reaction happens all at once because it's a one-step problem. So our transition state going to look something like this. It's also important that you draw this transition state during exams because it goes to show that you understand the concept. It's going to look something like this, but our final product looks like this. Okay, I hope somebody caught it if you were paying attention to what I was saying earlier. Because this carbon is chiral, technically this whole answer is wrong because the backside attack makes this switch. So our actual answer looks like this. You always want to make sure you're paying attention to the molecule and to see if it's chiral, because if you don't flip it, your answer is completely wrong. Okay, let's move on to the second problem. Same step. The nucleophile is going to attack our carbon. Then the leaving group leaves. So our transition state is going to look like this. But the final product don't forget to show the inversion if your carbon is chiral. Moving on to the last problem, same steps. Actually, I should have drawn this molecule like this to show exactly what's happening. Please draw it like this on the exam. Don't be lazy like me. But essentially, this is what's happening. Then our transition step looks like this, meaning that the final product is this. And inversion does not apply in this case because that was not a chiral carbon. Other than that, I hope I made SN2 a little bit more simple and easier to understand. Please feel free to ask any questions in the comments below or ask for a certain topic for me to go over next time. And please like and subscribe. Thank you.